standard Ethernet. If you observe here, the slide categories of standard Ethernet, basically there are four common implementations of standard Ethernet, which is named as say 10 base 5, 10 base 2, 10 base 3, and 10 base F. Okay. In this nomenclature, say generally we represent this type of standard Ethernet as 10 base X, where the number defines, okay, that 10, whatever 10 is written here, right? It defines, it tells that it is nothing but the data rate, say 10 Mbps. It indicates the data transfer rate is 10 Mbps. Okay. The term base means next term what you observe here, that is nothing but base. It means that we are using baseband, that is digital signal. Okay, we are transmitting a digital signal, and X. Okay, suppose say that in general we represent it as 10 base X. X is nothing but it can be any number. So what this X is? X is approximately defines either the maximum size of the cable in 100 meters. Okay, maximum size of the cable, it is in terms of hundreds. So it is written as 5 here. It indicates that 5 into 100. So the maximum cable length can be 500 meter. Okay, that is how the nomenclature here. So these are the different categories of standard Ethernet, which is nothing but 10 base 5, 10 base 2, 10 base T, as well as 10 base F. We'll just go through the detailed explanation of each types one by one. Okay, and coming to encoding, please mute from your side. Okay. Coming to encoding as well as decoding in the standard Ethernet, basically this all standard implementation, okay, is nothing but a digital signaling. As we have seen in the last PPT, it is baseband at 10 Mbps. Okay, digital signaling at 10 Mbps, and the sender data are converted into digital signal. Okay, whatever data you receive from the upper layer, it will be converted to the digital signal by this Manchester encoder. Okay, it is nothing but it uses Manchester's scheme at the receiving section. Also, the received signal is interpreted as the Manchester and decoded into the data. Okay, in this twisted pair, that is at it contains all the types what we have seen in the previous slide, different standard Ethernet. Basically, it contains a twisted pair of fibers. Okay, which contains both Manchester encoder as well as a Manchester encoder at both receiving as well as at the transmission side. Okay, we'll go through each standards one by one. The first one which you have seen in the type of the standard Ethernet is 10 base 5. As I told you earlier, this is a nomenclature. This representation tells that it gives information that 10 indicates the data rate is 10 Mbps. Base indicates we are following baseband, which is nothing but the digital signal, and 5 indicates it is the length of the cable what we can have. So it in terms of 100 meters. So 5 into 100 is nothing but 500 meter is the maximum cable length we can have. If we just go through the implementation here, okay, in this particular block diagram, say cable end, this total cable, it is nothing but thick coaxial cable, okay, through which our different devices or different systems can be connected. Okay, this cable length can be of maximum 500 meter if you follow this base 5 implementation. So this cable length is of maximum 500 meter, and you can observe here this follows a bus topology, right? Follows the bus topology in the sense in the entire bus, wherever the devices requires a communication, it will be central tapped or it will be connected to that particular section. Okay, we call it as a thick Ethernet. Okay, this particular configuration is also known as thick Ethernet, or in general we call it as thicknet. Okay, the nickname derives from the size of the cable. From where did we get that? Because this cable, which is nothing but a thick coaxial cable, from there that particular name has been derived. Okay, and which is roughly the size of a garden house, and to bend with your hand, it is very difficult to bend it, and it is like very hard. Okay, very hard type of cable, based 10 base 5 was the first Ethernet specification to use a bus topology with the external transceiver, that is both transmitter and receiver connected tap tap to a thick coaxial cable. This we call it as a tap, to which a thick cable is connected, and the length of this cable, thick cable through which is connected to a tap to the main coaxial cable, it can be only up to maximum of 50 meter, not more than that. Okay. The next type, as we have seen, is 10 base 2 implementation. Again, here also same nomenclature. 10 indicates 10 Mbps of data. Base indicates you are following baseband digital signaling, and 2 indicates the length of the cable, okay, which is nearly say 100 into 2 to 100 meter, but actually to be specific, it can be of 185 meter long, maximum of 185 meter long. So here you can observe this is also same configuration as that of the previous one. There it was a thick coaxial cable. The difference is with respect to the physical structure of the coaxial cable, and here it is thin coaxial cable, maximum length of 185 meter. So in the previous example, it was around 500 meter, but it was thick, very difficult, physically very difficult to handle, to bend that particular device handle. Whereas here it is easily we can bend it to the requirement, according to our requirement. Okay. So this second implementation is also called as thin Ethernet, or we call it as cheaper net. Okay. Sometimes it is also called as cheaper net, and also it uses a bus topology. You can observe here. This uses a bus topology. And this is much thinner as well as more flexible. Okay, the cable can be bent to pass very close to the stations. It can bend in any directions. In this case, the transceiver is normally part of the network interface card, that is known as NIC card, which is installed inside the station itself. Okay. Next one, if you observe, next type of Ethernet, standard Ethernet, that is 10 base T implementation, the third one. Okay, 10 base T implementation, which is nothing but third implementation. We call it as 10 base T because T indicates here 10 is nothing but 10 Mbps, base is baseband, whereas T indicates it is twisted pair. Okay, it indicates it is a twisted pair. Twisted pair here, if you observe the figure in this case, 10 base T uses a physical star topology. Okay, in the previous two topology, it followed a bus topology, right? A long coaxial cable was been connected in terms of a bus topology, whereas here it is star topology. Star topology in the sense we have a master block, we call it as a hub. Hub, different devices can be connected. Okay, different and based on the slots available, number of devices can be connected to this hub. Okay, so that is known as a twisted pair T implementation connection. The stations are connected to a hub via two pairs of twisted cable. Okay, note the two pairs of twisted cable here. This creates two paths, for one for sending, okay, and other one is for receiving between the station as well as the hub. Any collisions here happens in the hub itself. If there is any collisions between while transferring or something like that, in the hub itself the collision will take place. Compared to base 5, 10 base 5 or 10 base 2, we can see that the hub actually this hub entirely replaces the coaxial cable as far as collision is concerned. The maximum length of the twisted cable here is defined as 100 meter. Okay, this cable length, whatever length you have from the hub to the device, it can be up to 100 meters, not more than that, to minimize the effect of attenuation in the twisted cable. Okay, so this is the fourth type of where the star topology is followed. Through the hub, the connection is made. Okay, the next one, it is 10 base F implementation. Okay, 10 base F indicates here fiber. Okay, instead of twisted cable, here we have a fiber. Okay, fiber Ethernet. Although there are several types of optical fibers, that is 10 Mbps Ethernet, the most common is called 10 base F. Okay, 10 base F. This also uses a star topology. You can observe here, this particular section also uses star topology to connect the station to the hub. Okay. The stations are connected to the hub using two of optical fiber or fiber optic cable as shown in the figure here. This is for transmission and other one is for the receiving. Basically, any connection consists two cables, okay, two optic fiber cables. So this is a basic summary of the standard Ethernet implementation. As we have seen, there are four different types of standard Ethernet implementation, starting from 10 base 5, 10 base 2, 10 base T, and 10 base F. The characteristics, first one is a media. Here, the connection is done through a thick coaxial cable in 10 base 5, whereas in 10 base 2, it is thin coaxial cable, whereas here in 10 base 2, it is a twisted pair, right? Two twisted pairs for transmission as well as receiving. And in 10 base F, it is two fibers are connected for transmission as well as receiving. Maximum length, 10 base 5, it can be 500 meter of cable. 10 base 2, it is 185 meter. 10 base T, 100 meters from the hub to the device. Okay, whereas 10 base F, it is 2000 meter. Okay, in terms of optic fiber. Line encoding all follows all this method, which is nothing but base digital coding. We have seen it follows Manchester coding. Okay, all this Ethernet follows Manchester coding. So this is about the standard Ethernet and different implementations present in the standard Ethernet. Okay, coming to the efficiency of a device, efficiency of Ethernet is defined. If you observe it, efficiency, how to measure the efficiency of the Ethernet, okay, standard Ethernet, it is defined as the ratio of the time, okay, used by the station, okay, ratio of the time used by the station one to send the data, okay, time required by a station to send the data to the time the medium is occupied by the station, the medium, whatever medium you're going to transfer, okay, till what time that medium is available, and time required. So time required to send the data divided by the medium available for the, by this occupied by the station is nothing but it gives us the overall efficiency. Okay, and efficiency is given by 1 divided by 1 plus 6.4 into A. Okay, where A is the number of frames that can fit in one medium. Okay, A is nothing but the number of frames that can be fit in a medium. It can be calculated as A is nothing but propagation delay divided by the transmission delay. Time required to propagate a particular signal. Okay, so propagation delay by transmission delay gives you A. Substitute here over here. So if you consider any transmission medium or any Ethernet, if you want to find the efficiency, first you need to find the parameter A, okay, which is nothing but the number of frames that can be fit on the medium at that instant, which is totally depends on the propagation delay as well as the divided by the transmission delay. Okay, and substituting here, it gives us the overall efficiency of the device. So this is about the standard Ethernet, different types of standard Ethernet, and how to calculate the